All right, in grade 3 students. So I realized that I've had a busy week this week in person with a lot tennis going on. So I realized that I forgot to go back and work a couple of the quadrilateral proofs. Okay, so I know in the video we did this problem for my lesson that took 30 minutes, and that's why I stopped and was like, okay, I'll come back to it, but I never did. So many apologies for that. I'm going to work number 4 and number 5 to make up for that. So that hopefully should be helpful for you guys. And let's talk about the process that you need to go through to be able to do these. So we'll repeat that now. Number 4, you're not given any shape. Okay. So it all begins with finding all of these slopes and all of these lengths. Okay. So let's go ahead and write this out. So to find the slopes, you have, I'm going to insert an equation here. Fraction, we have y2 minus y1 over x2 minus x1. I don't feel like doing the subscript. So we can use this equation to help us out. If that keeps things straight for you, then go ahead and do it. And so we're starting with Mike. So y2 is 4, y1 is 1, so 4 minus 1, that's going to be 3. Okay. Then we have 6, take away 4, so the change is 2. So we have 3/2 is going to be our slope for this one. So that's what we begin with. Now we're going to repeat this process for the rest of them, but for IK, I'm going to do it a little bit differently. I'm just going to look at the actual points. I'm going to say, okay, how do I go from 4 to 0, right? Well, that's a -4 change, okay? -4. And then how do I go from 6 to 12? Well, that is a +6. So the actual slope for this is -2/3, okay? Now we're going to do KE. And if you like y2 minus y1, x2 minus x1, go for it. Use it. It will always work. But it's also good to practice doing this with just looking at the points and saying, okay, it's the change. That's what I'm looking for. So as I go from 0 to -3, that means we're taking away 3. 12 to 10, we're taking away 2. Okay? And so these slopes are going to become positive. Okay, 3/2. All right, let's do the last one, which is EM. So EM, we're going to erase this. So from E, we're going from -3 to +1. So that means we are adding 4. And then we go from 10 to 4. So that means we're taking away 6. And I think my screen, there you go, taking away 6. So we simplify that, and that gets us -2/3. And I actually want to do that to this one up here, with the negative out in front. There we go. All right, so we have all our slopes. So on Delta Math, we want to go in here. We're going to do -2/3. Wait, is that what we got? No, it was 3/2. Whoops, make sure you put the right one. So it's 3/2. -2/3, then we get another 3/2, and -2/3. So these types of problems, it's almost like a quadrilateral scavenger hunt, kind of. That's what we're doing here. And we're gaining the information about the shape that we don't see through this information. So the slopes, what we notice here is that these opposite sides, MI and KE, they are parallel to one another, okay, because the slopes are equal. So we see the same thing with IK and EM. Those slopes are parallel to each other. So automatically that means it has to be a parallelogram, okay? Now, is it a special type of parallelogram like a rectangle, a square, or a rhombus? Maybe. We have to look for other information within the slopes as well. So notice how the adjacent slopes are opposite reciprocals. So that's what we talked about when we say perpendicular, right? So slopes that are opposite reciprocals are perpendicular. They're going to intersect at a 90-degree angle. So we can imagine this shape has parallel opposite sides, and the neighboring angles, the word adjacent means neighboring, they're intersecting at 90 degrees. So this actually can't be a rhombus, or it's more specific than a rhombus. So it can be a rectangle or it can be a square. It can be one of those two. So this is the thought process that we go through when we're working these problems. So how do we know if it's a rectangle or square? What's the difference? Well, a square is going to have equal lengths for their sides. A rhombus is going to have, or excuse me, a rectangle is going to have opposite sides congruent. Okay, but we already know that it's 90-degree angles. Okay, the adjacent sides are perpendicular. But let's go ahead and find the lengths for this. So for the lengths, we introduced a distance formula, and that looked like this. We had, I need a math function. It was d equals, and we had a square root. If I can find my root button. I had it last time, but now I've forgotten where to get it. No. I remember finding this last time. Oh, it's right here. Okay. So we have y2 minus y1. We'll square that. I'll square that in a second. Plus x2 minus x1. That is our formula. Let me just add the squares to it. So we have to square. And what you'll notice is this is the actual, it's the slopes. So look here, it's the slopes of the lines that we found. So we're really using the slope to help us find these. So I'm going to do that. So here I'm going to do square root. We're going to take 4 minus 1, which was 3, and we're going to square it, plus 2 squared. Okay, so 3 squared is 9, 2 squared is 4, so 9 plus 4 is 13, so we get square root of 13 here, and we're not going to be using decimals for this, we're using exact values. So let's do the next one. Square root, we're going to look over here. We're not using the simplified slope, so I don't care about this negative 2/3. I have to use the original changes in x, changes in y, and put those in there. So it's negative 4 squared plus positive 6 squared. All right, so that is 36 squared is 36. Of course, if you want to use a calculator to do this, you can. That's totally fine. So this would be, make sure that you use parentheses around your negatives. That does matter. That matters quite a bit. You will get the wrong answer if you do not use parentheses here. So 6 squared. Now that is, I need to make sure that it's not a decimal. So I'm just going to do this to see what's inside. So it's 52. So this is square root 52. Okay, square root 52. So that's going to be my length for that one. Let's do the next one. I'm going to draw it down here. So this is KE, length. So let's go ahead and make our square root. So we have KE, we had negative 3 and negative 2. So negative 3 squared plus negative 2 squared. Now these negatives, you'll notice, are always, when they get squared, going to become positive. So this is actually equivalent to what we did for MI. 3 squared plus 2 squared. This is negative 3 squared plus negative 2 squared. 9 and 4. This is actually going to get us the same thing. Square root 13. And then we'll do EM. And EM is going to be positive 4 squared plus negative 6 squared. So we get, we're going to get the exact same thing as we did up above. So we have all these links, so we're going to go ahead and type those in. There's a couple ways to type in the square roots. Students have been asking me in person frequently about this. You have the square root symbol down at the bottom. You're more than welcome to click that. Or there, I don't know if it's faster, it might be for you. If you type SQR and then T, it'll make the square root for you. So watch as I type T in here, boom, it makes it a square root. So SQ is square, RT root, okay, if you want to do that. So we're putting 13. I almost think it's faster to type SQRT. Okay, 13, SQRT, 52. So there's our links. All right, so what does this actually tell us? Well, look, opposite sides are congruent here, but are all sides congruent? No, so it's not a square. It is a parallelogram that has right angles, okay? And that means it's a rectangle. That's what it's telling us. So we go through here, and this is like our questionnaire about it, okay? We're looking at the information that we gained from slopes and lengths. Opposite sides, are they parallel? Yes, we showed that. Here's the opposite sides. The opposite sides are always going to be the ones that are one space away from each other, okay? Adjacent sides, perpendicular, yes, all of them. Every single, as you go, every other side, it's flipping and changing the sign. Flip, change the sign, flip, change the sign, every single time. So the original, flip, change the sign, flip, change the sign, flip, change the sign. There it is. All sides congruent? No. Okay, if they were, all of these would be equal. Okay, they're not. Opposite sides congruent? Yes, that is true. 52 and 52, square 52, that's IKEM. These are congruent as well. Adjacent sides congruent? No, they're not. Okay? Exactly one pair of opposite sides parallel? That's not true. Based on the information given above, it is a rectangle. We submit. There we go. I've definitely been very concerned about distance learners doing these problems just because there's so much room for error. You obviously have 50 attempts here, but 15 parts, there's a lot that could go wrong. But I'm definitely happy that, I'm upset that it doesn't tell you which parts you got wrong. I wish it would. So if you need individual feedback, try to send me a question and I can mark it for you what you got right or wrong. But hopefully you're able to go back through it and double check everything, but definitely send me a question if you have it. Let's look at number 5 here. Same process is going to happen with this one. We have quadrilateral jack, has these vertices. Use coordinate geometry to find what shape it is. So we're going to do the exact same process. I'm going to go a little bit faster this time through it. So I'm actually going to do a lot of this typing, okay? So let's do this. So jack, what is the change in y? Well, it's -4 to 2, so we're adding 6, and we're going to divide that by, we're going from 1 to 10. Okay, so the change in the y values is 6. The change in the x values is 1 to 10, so that's +9. So 6/9, that is equal to 2/3. So there's our slope for that first one. Let's do the next one. Equals. We go from A to C, so 2 to 5, we're adding 3. 10 to 8 is -2, so that equals -3/2. Okay, -3/2. All right, next. So far, these are looking like they are right angles. Those are adjacent sides that we just did, JA and AC. They are opposite reciprocals, so right now they are perpendicular. Let's do the next one. 5 to 1, so that is a change of 4. 8 to 2 is a change of 6, which gives us, again, 2/3. Okay? 2/3 is the slope. We'll do another one. Alrighty. So, we're going from K to J. So it's 1 to -4. That is equal to -5. And we're dividing by, from 2 to 1, that is -1. So we're taking away 1. So the actual slope on this one is 5, +5. All right, so there's all our slopes. I'm gonna go ahead and type those into to Delta Math. Let me move it over here. So we have 2/3, tap down, -3/2. We have 2/3, and then we have +5. It's kind of a weird shape. We have a pair, these are parallel here, okay? This one is perpendicular to these sides because it's the opposite reciprocal right there. But then this 5 kind of throws everything off. It's kind of weird, okay? But that should be correct what we did there, okay? So now we're going to, and I'm going to write these out just because it is faster with the roots and such. we need to find the lengths. Okay, so let's go ahead and find our lengths. Remember, we're using the original changes right here. So I need 6 squared plus 9 squared. So that should be 81 plus 36. 81 plus 36 is something 07, so 81. So that's 117, so square root 117 right there. We do the next one, so we're going to do 3 squared plus negative 2 squared. And we should get square root. This is going to be square root 13, just like the last problem. Do the next one here. We're doing 4 squared plus we have 6 squared. So that's 16 plus 36. Actually, sorry, 16 plus 36. That's going to be square root 52. And then we do the last one, which is going to be, it's not just 5. We have negative 5 and negative 1. So negative 5 squared plus negative 1 squared. Okay. So that's going to be 25 plus 1, so square root 26. So let's put all of those in. So, oops. All right, so let's do that. So put in our links, SQRT. We have 117, 13, 52, and then 26. So those are our links. Now you'll notice none of these links are congruent at all. Okay, so we know it's not a rhombus, we know it's not a rectangle, and we know it's not a square because the opposite sides aren't congruent either for the rectangle. We don't have all perpendicular slopes either. Okay, so now we're able to interpret what's going on with this shape. Okay, that's what we need to do. So we answer the questions. Are the opposite sides parallel? Well, just one pair of them, right? Just these two. So a lot of these statements say, are all of them, right? That's what we're saying. So this is a no. Adjacent sides perpendicular. Well, we have a couple, but not all of them. So we're going to say not perpendicular. All sides congruent? Definitely not. Opposite sides congruent? No. Are adjacent sides congruent? No. Then we have this question. Exactly one pair of opposite sides parallel. Well, we do have that. 2/3 and 2/3. JA and CK. So that's a yes. So based on all of that information, we have our quadrilateral hierarchy that we use, and we have the different shape properties. What shape has exactly one pair of parallel sides? Well, that would be the trapezoid. Okay, and we got it right. Okay. All right. Hopefully this is helpful in getting you finished with this with these problems. Reach out to me. I know this is due. It is today is Thursday, so it is due tonight. So make sure that you start chugging away at that.